Alright, today we're going to talk about triangles. So the first thing we need to remember is our Pythagorean theorem. You guys might remember it as a squared plus b squared equals c squared. But really, the reason why I have L1 squared plus L2 squared equals h squared, it's the Pythagorean theorem is leg 1 squared plus leg 2 squared equals hypotenuse squared. Doesn't matter which one you use where, just matters that you know the equation. So if you remember a squared plus b squared equals c squared, that's fine too. I'm not going to do any exact examples of the Pythagorean theorem because I think you guys understand the Pythagorean theorem. I will go over something though. If I'm giving you guys three sides, do we know if it's a Pythagorean theorem or if it's a right triangle or not? And the way we tell is we use Pythagorean's theorem. One thing you got to make sure you remember is that the hypotenuse is always the biggest side. So if 6, 3, and 4 are valid sides for a right angle, a right triangle, we know that this has to be our h, our hypotenuse. If you guys want to use the c, that's fine, use c. We also know that 3 and 4 have to be our legs, so we know that 3 squared plus 4 squared, does that equal 6 squared? Well, 3 squared is 9, plus 4 squared is 16. 9 plus 16 is 25. Does that equal 36? It doesn't, so we know that this triangle is not a right triangle. And if I learned how to spell right, it'd be better, right? All right, let's try the next one. So we know that 13 has to be our biggest side, so 5 squared plus 12 squared. Does that equal 13 squared? Well, 5 squared is 25, plus 12 squared is 144. This is 169. 13 squared is also 169. Those are equal, so this is a right triangle. Again, forgot how to spell right. So, in order to test 3 points, 3 sides to see if they're right triangles, you just plug it into Pythagorean's theorem and see if they end up, the two smaller ones squared and added together, do they equal the square of that third longer side? At any time, if you guys need me to pause, or you need to pause the video, go back, rewatch anything you need to watch. All right, I'm going to explain both of these. I know they're a little lengthy, so I'm expecting you guys will pause this, write this down, have it in your notes. But really, what this first piece is saying is that across from our largest side of a triangle is going to be our largest angle. And across from our shortest side is going to be our shortest angle. And so really what this is saying is if I have a side that's longer than another side, then the angle opposite the longer side is going to be bigger than the angle opposite the shorter side, and vice versa. So if you want to write down verbatim what's on the board or on the screen, make sure you pause right now, write it down, and have it in your notes. All right, so here's an example. I'm going to list the sides in order from longest to shortest, but if you notice, I don't actually have the side lengths, but I do have the angle measures. So if I'm listing from the longest to the shortest, that means I need to look for the biggest angle measure, go across from that. So AC here is going to be my longest side. So AC is the longest. Then we're going to go in order from back down. So the middle side is going to be across the middle angle. So across from 40 here, we're going to have AB. And then our shortest side is going to be across from our shortest angle, so BC. If that was too quick, go ahead and pause, rewind, rewatch that. And it works the same way if I have side lengths to the smallest, biggest angles. Again, if I'm going too fast, make sure you pause, rewind, watch whatever you need to over again. Let's talk about the triangle inequality theorem. What the triangle inequality theorem says that the sum of any two sides of a triangle has to be greater than the third side, the biggest side. So the easy way to tell if it can be a triangle is just take your two smallest sides, add them together. Are those bigger than our longest side? So let's do some examples. Can these three side lengths be sides to a triangle? All you have to do is take your two smallest sides, add them together, and is this number, is 7 greater than 6? Well, 7 is greater than 6, so it can be a triangle. Yes, it can be a triangle. Let's try another one. If we have 3 plus 4, we still know that that equals 7. Those are our two smaller sides. We're going to compare 7 to 12. Well, 7 is less than 12, so no, these three cannot be a triangle. Let's look at the next one. We have 3 plus 5. That equals 8. And our third side is 8. Well, 8, how does 8 compare to 8? It's equal to 8. Those aren't bigger, so it's no, they cannot be a triangle, because what will happen is it'll just end up laying flat on top of it, and you'll have a line on top of a line. Well, now that we know the triangle inequality theorem, let's go and let's look at possible side lengths that we have. So a triangle has one side that is 12, another side that's 4. Describe the possible third sides. Well, really, there's two different options I can have here. The first option is if I draw a triangle and I have 12 be my longest side, and then I'll have 4 as my other side. Well, we know that this next side, this question mark side, it has to be a number greater than, added together with 12, so 4 plus question mark has to be greater than 12. Well, if you look at that, well, I'm going to look at, well, what number makes it equal to 12, because I know the number's got to be bigger than 12. So really all we have to solve for is question mark has to be greater than 8. Subtract 8 from both, or sorry, 4 from both sides, and we'll know question mark is bigger than 8. We also have a second problem, though, that we have to look at, and that is, what if 12 isn't our biggest side, but the missing side, the question mark, is our biggest side? Well, again, we're going to look at 4 plus 12 has to be greater than question mark. Well, really, I just need to add 4 plus 12 is 16, has to be greater than question mark. So really what this question has two answers. We have our small answer, which is 8, and we have our big answer, which is 16. And I'm going to put a variable in the middle there. It doesn't really matter what you put. We all like to put x because that's the one we always use. But that x, that tells you that the numbers, any number between 8 and 16, not being 8 or 16, could be my third possible side length. So any number greater than 8 but less than 16. All right, we have two more examples, and I want to make sure you guys understand that these pictures are not necessarily drawn to scale. So you can't use the idea of using it to scale. So first thing I'm going to do is I'm not even going to look at my problem like it has variables in it. I'm not even going to look at variables on it right now. I'm just going to think, what possible side lengths can that be? And all we have to do is we take our two side lengths that we have. The first side, when we go to the smaller end, we're going to take 14 as our biggest number, subtract 9 away. That's going to get us our smallest possible way that we can go, and we can't be any smaller than 5. In order to get the bigger side of it, we need to take our numbers 14 and add 9, and we'll get 23. We know that the numbers are going to be in between there, and last time we talked about is we're just going to put an x in there, but now we have more than just the x, so we're going to have to put in the 5x minus 2. Now we have to think back to algebra, solve this solve our inequality. If I add one piece to any side, I have to do it to every single piece. So we get 7 is less than 5x is less than 25. Divide by 5. So our actual answer is we need to be bigger than 7/5, but we have to be less than 5. X has to be in between 7/5 and 5. Okay, that's the lesson for today. Make sure you guys rewatch anything you need to rewatch. This will be up on Schoology, so if you need to rewatch anything, you can watch it on there. Otherwise, that's all we need to do. Guys, work on your homework now, and let me know on Monday if you have any questions.